TCP connection management. So TCP connection management is a very interesting topic because many of the most common network attacks, including the incredibly popular SYN flood attack, exploits the vulnerabilities of or vulnerabilities in TCP connection management mechanism. So we would like to see this as well. So here, I should write it here because I'll be discussing it in a minute. So we have to understand it why, because the SYN flood attack basically it targets the three-way handshaking mechanism of TCP. So let me quickly recall that a TCP. Let us quickly recall that a TCP sender and receiver has to establish a connection before exchanging segments with each other, right? And for this reason, a server is always listening on a specific port for the incoming connection, and client can initiate a connection by initializing a socket object, identifying the host IP address, means the destination server's IP address, and server's process address, port number. And it's both server and the sender initializes initial sequence numbers and buffers for flow control information that we'll see in a minute. So TCP uses three-way handshaking process, right? Means there are 3 steps involved in the connection establishment of TCP. The first step is that the client host will send a special segment known as SYN segment, right? So it will send a special segment known as SYN segment to the server by setting SYN flag. Remember when we talked about the TCP segment header, we discussed 6 different flags inside TCP segment header, and we identified a set of 3, R, S, and F. And we said these 3 flags are used for connection establishment, resetting, and termination, right? So this special SYN segment is generated by setting this SYN flag by setting its value to 1. And it has some initial sequence number, but it has no data associated with it. Why? Because we have not established our connection so far. It's a connection request, by the way. So this special SYN segment is acknowledged by a SYN segment, right? So this SYN segment is generated by the server by setting the SYN flag. And if you remember, there was another flag known as acknowledgement flag. Okay, so it not only sets the SYN flag, but it also set the acknowledgement flag. The server replies with the help of a special segment, which is known as SYN segment, SYN segment, by setting the SYN flag and also the acknowledgement flag. And server also allocates buffer here. So buffer to receive whatever data coming from the sender side, and it also uses or randomly selects the initial sequence number. And here we have the problem, right? So this initial sequence number or this allocation of the buffer makes TCP vulnerable to a denial of service attack. So this makes the TCP vulnerable to a denial of service, is DOS, denial of service attack. Okay, so which is also known as, by the way, SYN flooding. Okay, denial of service attack means here I'm talking about SYN flooding. So in a minute we'll see what are the possible solutions. So let us first discuss this 3-way handshaking process. And now, in response to this SYN segment from the server side, the client machine sends an acknowledgement to this SYN by setting the acknowledgement flag only. And in this case, we can also attach the data with this segment. Since we exchange three messages, or there are three steps involved, we call it three-way handshaking mechanism. But there are a couple of questions that I want to raise for our online sessions discussion. Number one is, what do you think? Why are initial sequence numbers needed? So remember, whenever this a special SYN segment is generated by the client machine, it uses a special randomly selected initial sequence number, and same is the case with the reply from the server side. So the question is, what do you think? Why do we need to have this initial sequence numbers, and why we select it randomly? And then the second question that I want to put here for our online discussion is, what do you think? Why is a three-way handshaking and why there is a three-way handshake as opposed to say as opposed to two-way handshake. Two-way handshake needed. So what do you think? Why do we have two-way handshake? What if we have a three-way handshake? What if we have a two-way handshaking process where the client is sending a special SYN segment and it is being acknowledged by a special SYN ACK segment from the server side? What do you think? Where we can have deadlocks? Can we have deadlocks? By the way, this is another question for our online session: is can we have a deadlock in three-way handshaking? Or if we are not using three-way handshaking, let's suppose we are using two-way handshaking, what do you think? Can we have a deadlock in two-way handshaking? Right. So we think about these questions, and we'll discuss these questions in our online session. Let's try to understand this TCP connection establishment mechanism with the help of an example here. So let's assume that a client has to establish a connection with the server. So this client will send a special segment, which is called, we know this, which is called SYN segment. By setting what? By setting this SYN flag. And this initial sequence number is generated randomly. And when server receives the SYN segment from a client, because server is listening on a port all the time for incoming connections, it generates a segment by setting SYN flag and by setting acknowledgement flag. And we know this, that this is called SYN ACK segment. SYN ACK segment. And here again, the server selects the initial sequence number randomly, and here is the problem. Here, this is why we can have a SYN flood attack here. This is a cause of SYN flooding attack. Okay. So we'll see how in a minute. Okay. So and when this client receives this SYN ACK segment from the server, it replies with a segment by setting the acknowledgement flag, and here we can also send data in this segment. And this is how a connection is established between a client and a server machine. So let's see how we can, what is the SYN flood attack, by the way. So SYN flood attack is among the first documented DOS attack, right? Fortunately, you know, an effective defense, which is called SYN cookie. SYN. So there's an effective defense to this SYN flooding attack, which is called SYN Cookies, is available, and SYN Cookies are now deployed in most major operating systems. By the way, the details about the SYN Cookies are given in request for comments 4987. Okay. So what is this SYN cookie? The SYN cookie is, so now this SYN cookie or a cookie, you know, this cookie is basically a complicated function. By saying complicated, I mean hash function. Hash function used to generate the initial sequence number. So in this case, in SYN cookies or a cookie, the server will generate an initial sequence number using hash function. And this initial sequence number now is called a cookie. By the way, this hash function or this complicated function involves source IP address, destination IP address, source process address port number, destination process address port number, and plus a secret number, right? So you know, you can say that you know, this secret number is known to server only, right? So plus a secret number. So I will take all these value, I'll do a hash function, and whatever the result is called a cookie, and this will be the initial sequence number that will be advertised by a you know, that will be the initial sequence number of the SYN ACK segment generated by the server side. Okay, so this carefully crafted initial sequence number, which we call cookie, will you know, make sure that server will only accept connections from the legitimate client, by the way. So the other difference is, so in the previously, without having a cookie, whenever there was a request from the client, server after generating, you know, this SYN ACK segment allocates buffer for this this client for incoming data. But now in this case, when server generates the initial sequence number using this hash function of source IP address, destination IP address, source port number, destination port number, plus a secret number, it does not allocate buffer. And now server waits for the response from the client side. But here the question is, how does the server make sure that now this response is from the legitimate client? So what the server does is that it takes the sequence number of, which is obviously the last byte number, which is because there's no byte here, y plus 1. It takes the sequence number here, and it again takes the source IP address, destination IP address, source port number, destination port number, plus the secret number, and adds 1 into it, and again it calculates the hash function and see if this number is same to this the sequence number of this acknowledgement as in the third step from the client. This means this is a request from the legitimate user. Okay, so then only server maintains or allocates buffer for the the client side. So what was the problem previously? So when the client was generating a SYN segment, and server maintains or allocates buffer for it and generates a SYN ACK segment. So there's a possibility that malicious clients are sending requests. So this means server will keep allocating buffers for malicious requests, and whenever there is a legitimate client, maybe server resource is not available because of this DOS attack known as, because of this DOS, denial of service attack known as SYN flooding. So servers resources not available to provide services to this legitimate client. Okay.